Guys, today we're going to talk about lesson 6, and lesson 5 was really short. Lesson 6 is going to be really long, so it's going to take more than one video to get through this lesson, so we'll just kind of take it in pieces. So the first thing I want to do is I want to look at this section, and I want you to be able to type these into your calculator. So I want you to look at your calculator and try to find the log button. So yesterday I had you find Euler's number E. It should be around the same area. You might also see that's a special kind of log. All of these should be about in the same area. So please take the time, push pause, and look for it, and then come back. Okay, so once you've found it, what I want you to do is type this in as you see it, parentheses included. So I want you to do all of these, push pause and come back, and we'll see if we have the same thing. Okay, so you should have gotten these three answers for your solution. And so I want to point out something. So right now, this doesn't really mean a lot to you. You're just kind of punching in some numbers. But notice the pattern that you see here. So we know that logarithms have something to do with exponents. So, sorry, I'm making bread. So if we have a pattern here, this one you shouldn't have been able to do in your calculator. So what would our answer be? And if you said X, sorry, you are correct. Okay, so I just said that logarithms have something to do with exponents. So let's go back to something that we're familiar with. So I want you to take each of these exponents or each of these problems and see if you can figure out what the exponent is. So like 10 to what power equals 1,000? 3 to what power equals 81? So kind of try to play around with those numbers, and we'll come back and see what you got. Okay, so hopefully you got 10 to the third power is 1,000. 3 to the fourth power is 81, and 4 to the second power is 16. So the problem lies with, this became a problem. So I don't know what 10 to the x power is. I don't know what that exponent is. It's not easy. I know that 10 to the first power is 10, and I know that 10, to the second power is 100, and I know that 47 is somewhere in there. I just don't know. So I know it's somewhere between 1 and 2, but I don't know what it is exactly. So that's why logarithms were created, so we can get to that exponent. So it's actually, we're going to talk a lot about this later on in this video, but it's actually the inverse. A logarithm is an inverse of an exponent. So if I were to type this in my calculator, I would get about 1.672, yucky. It just keeps going and going. So if I took this number and plugged it in as an exponent for 10, so if I said like 10 to the 1.672 power, that's going to get us pretty close to 47. So we are going to set up logarithms to help us kind of navigate around that. So I'm going to start off with what we know. So we have a base and we have an exponent that's equal to a number. So we have this guy right here. So like 10 to the x power equals 47. Well, I'm going to rewrite this as a logarithm. So that b, that's going to be my base of my logarithm. So it's going to go there. My number is going to go here, and logarithms are always set equal to an exponent. So my exponent goes here. So what I'm going to do is I'm going to rework these in a way that it becomes a logarithm in this next section. So I want you to come down here, and I want you to, let's go up here. So let's take this one for example. So I'm going to rewrite this as a logarithm. So it's going to be log base 10 of, n, which is 1,000, equals x. So this one would be log base 3 of 81 equals x, or we found these, which we could equal it to 4. So that's a process there. Okay, so let's go down here, and now we're going to go the other way. So we're going to say, what does this look like in exponential form? So I'll do the first one for you. So it's going to be 2 to the 5th power equals 32. So I don't know about you, but this really doesn't make a lot of sense. But when I put it into exponential form, I know 2 to the 5th power equals 32. Like we've talked about exponents before, so that kind of makes a little bit more sense to me. So what I want you to do is go through each of these and see if you can rewrite them as exponents. Okay, so this one I have 10 to the 0 power equals 1. Well, I know that because anything to the 0 power is 1. 9 to the 1st power is 9, which makes sense. This one, notice the negative. So that means I'm going to flip it to 5 squared, and that's going to give me 25. Makes total sense. So that's where our comfort level is. Now these, we don't have the equal sign. So I want you to think of each of these as an x, and then see if you can solve for them. So for instance, this one is going to be 3 to the x power equals 81. And then tell me what x would be. So try it with each of these and see what you can do. Some of them are more difficult than others. Okay, so this first one's pretty easy. 3 to what power equals 81, and that's 4. This one, notice this one's very similar to that one up there. So this is 1/4. So I know that to go from like this fraction to a whole number, it's going to be a negative number. So I know that. So let's flip the 4. So 4 to what power equals 256? That's what's going through my mind. So I know it's negative. So it's going to be a negative 4. Okay, this one, same thing. So I'm going from a bigger number to a small number. So I want you to look at this as 0.001. That's the same thing as 1 over 1,000. So we're kind of going opposite of this direction. So I know that my x is going to be negative again. So I'm going to look at this as 10 to what power equals 1,000. And so that's going to be 3. So my answer is going to be negative 3. And then finally for the last one, this one, notice I'm going from a big number to a small number that's not a fraction. So that gives you like a root. So we know that we're going to deal with some root. So 64 to what root is 2? Remember how like exponents are the inverse of roots. So like what's going in my mind is like 2 to what power equals 64. And so your answer to that would be 6. So my root, let's change color so you can see easier. My root is going to be the 6th root of 64 equals 2. So do you see how that works? You go backwards. 2 to the 6th power, 64. The 6th root of 64 is 2. So then my x would be that root. So let's think about that root as an exponent. So remember, when you have a root, exponents on top and roots on the bottom. So my answer would be 1/6. That one's kind of a tough one. We'll have some more practice with those. The next section, we are just going to use our calculators to just kind of play around with these numbers. So use a calculator to evaluate. That just means we're typing it in our calculator and we're going to get a yucky number. So let me go ahead and give you the answers to these. And so I think the best thing would be to just push pause and see if you can get all of those answers. Again, look for that. It has to be that LOG button. And then this one, notice the difference. This is LOG and this is LN. So notice the 2 different buttons that you need on your calculator. Okay, so once you've done that, hopefully you've found them on your calculator. If you haven't, if you can't find it, let me know and I can Zoom with you and help you find that on your calculator because you are going to need it for your test. So let's just talk about what LOG is. LOG That's called the common log. And it is log base 10. So this is used a lot of times in like finance and things like that. So they were using it so often, this base 10, that they just called it a common log. Sorry, that looks hideous. And so when you see that, that's actually what you're using is log base 10 for the LOG. So the 10 is always implied. Okay, so this next one, the LN, that's called a natural log. And that's used a lot of times in science, like especially biology. Things grow or decay using this natural log. And so what that is it's going to be log base E. And so this is used in science. So when you type it in on your calculator, when you have it like in this form, you don't really need to know that. But later on, it's going to become important that you know that the common log is log base 10 and the natural log is log base E. Okay, so right now what I want you to do is put these, this kind of is a review of everything, but I'm going to include these two at the end. But what I want you to do is see if you can answer these 4 problems, push pause, and then come back to see if your answers are correct. Okay, so these are your 4 answers here. Notice on this one, I kind of explained how I got that 1/3 because I know that can be tricky. And then these last 2, I literally just did on my calculator. So that's all I want to put in this video. What I would suggest doing is going to your practice, and like the first part of your practice just deals with this stuff. So go ahead and try that, and then I'm going to put the rest of this in another video. Thanks a lot, guys.